the wall 12 meters away. Stop. Create my picture here. So this is 12 meters away. And here's my spotlight. And this is the wall. Good. So this is the information I have from the very first sentence. If a man 2 meters tall walks from the spotlight towards the building at a speed of, okay, wait a minute. Here is the man. Sorry, I don't know how to draw a man. So he is 2 meters tall, okay, and he walks this way from the spotlight to the wall, okay. From the spotlight at this instant, he finds itself at X meters away from the spotlight. So now let's continue. Let's read this one more time. If a man 2 meters tall walks from the spotlight towards the building at a speed of 1.6 meters per second. So something is 1.6 meters per second. What is it?
Would it be dw over dt again?
We don't have W, unless you want to denote this by W.
Dx over dt?
The X over dt. Perfect. If you want to denote it by W, we can. It doesn't matter. Good. How fast is the length of his shadow on the building decreasing? So what kind of rate do you expect if it says decreasing?
Negative.
Negative rate. When, forget about this, right? I got to the word when. Forget about what follows next. So when he is 4 meters from the building, okay? One more time. How fast is the length of his shadow on the building, okay? I'll come back. I have to extend the wall. So this is y. When he's here, this will be y. So obviously, the closer he is to the spotlight, the bigger the shadow. The closer he is to the wall, the further away from the spotlight he walks. I mean, he finds himself at this instant. Then obviously the shadow is much smaller. So let's go back to the problem. How fast is the length of his shadow on the building decreasing when, I don't care, when he's 4 meters from the building, I have to put it in, but this does not come into play. It follows after the word when. 4 meters away from the building. So the question is, so 4 meters away from the building means that X is how much?
12 minus x. I'm sorry.
Yes.
12 minus.
Yes.
8.
That's true. Correct. But what are we asked to determine? That's the key now. See how important? Yes. Sorry.
Well, dy over dx.
You mean dt. They're all
dt.
functions of time. Correct. Excellent. So see how important it is to have the figure at the same time with reading the problem, because you may need to identify certain variables, so to speak, functions of time. So you have to use certain letters for different things. So this is fixed. This has to be put in the problem from the beginning. This does not change. But this changes, it's a function of time. This changes is a function of time, not the height of the person. Okay, so we established that he walks, in other words, his rate of change of x with respect to time is 1.6. At the same time, when he walks towards the wall, then his shadow is changing with respect to time. And this is what we are asked, and forget about this. So now I'm going to take that out of there because I need to explain what is the next step. So we know that this is y. The person is at some point in time is here. We know that this height, his height is 2. We know that this is denoted by x. And we know that this is 12. And there is something that we can do here. The tiny triangle.
The small triangle is a ratio of the entire triangle.
Yes. Two similar triangles. Two similar triangles. Similar triangles, I have to show and explain why. They have to have basically two congruent or equal angles. These are equal because they are 90-degree angles. And this is a common angle. So obviously, these two will be identical as well. If these two are equal and this is a common angle, these two have to equal each other for sure. So two similar triangles, since they have, and we showed how I labeled them correctly, since they have, we like to say congruent, but I'm going to simply say equal angles. Equal angles. Correct, to be exact, to have pairs of equal angles. To be exact. Okay. Then we can write proportions with, so from here, the result is we can write proportions with the sides. But we have to be very careful because the order is very important. So let's say I start with a common angle. And so all the sides at the top have to come from the same triangle. So I'm going to bring them from the small triangle. All sides in the denominator have to come from the big triangle. This is my choice. You can reverse it. It doesn't matter. So I start with a common angle. The opposite side of the common angle in the small triangle is 2. The opposite side of the common angle in the big triangle is y. I move on to the next angle. Who cares? I don't have these. I move on to the next angle. This angle has an opposite side, which is x, in the small triangle. The congruent or equal angle is this, which has 12 as the opposite side. So now I have a proportion. 2 over y equals x over 12. Can anyone cross multiply and tell us what we have next?
X times y, 24.
Excellent. Perfect. What did we say about x and what did we say about y?
functions of time.
Both functions.
Functions of time. Excellent. I'm ready when you are. Be careful and tell me which rule we apply here.
Product rule.
Product.
Excellent. I'm ready.
X dy.
Dx over dt times y plus
dy over dt times x.
very good, x times dy over dt. Perfect. And the right hand side?
0.
Excellent. Stop. Let's take a look. This is what I want. And later on, I'll look where. But right now, this is what I want. Can anyone solve this for us?
X times dy over dx over
You mean y times d, so y times dx over dt over x, but of course with minus in front. So this piece goes here, changes its sign, and now I have to divide by x to get dy over dt. Let me write it one more time. So dy over dt equals negative in front. You can write it as y over x dx over dt. Now, only now, I look at what follows after the word when.
Why do we change the sign?
Because I move a term from one side that is positive to the other side and becomes negative.
Oh, we're subtracting.
Yes. So only now. Okay. Fine. But if x is 8 in this equation, how much is y?
3.
Yes. So now I can continue as negative y over x 3 over 8 times dx over dt, which was given to us from the very beginning. That's fixed. 1.6 meters per second. So if I divide by 8, I get 0.2. So this is negative 0.6. Measurement unit.
Meters per second.
Yes, I think it was meters per second. Correct. As expected, as a negative number. Right here. So his shadow on the building decreasing when, so remember, this cannot be taken into account. You cannot put it in till the last second of the problem. Okay, let's see. I have 7 minutes left. We can at least start another problem. I want to look for one with an angle. We have one with an angle here. Ah. Kite.
So we're just able to take dx over dt away from over x.
Very good. So if I have like negative a times b over c, I can write it as negative a over c times b.
Is that only when it's negative?
No, it doesn't matter. This is a product. So
Okay.
it's a product. So let me show you better here. So if I have a times b over c, I can write it as a over c times b. So what we had was y dx over dt divided by x. It's the same thing. I can put this over this over this, and then b at the side. on the side. So it's like A is Y and B is this and C is this. So I can write it like this. I can even
Okay.
put B in front if I want to. I can switch these two because AB or BA mean the same thing. Any questions on this problem before we probably you have to stop or look at something else? Other questions here? And let me ask you, how do you feel about related rates?